Mara kuzoba awkward ngihlale for 10 minutes.
No, I need you to put on the timer.
Okay.
You can say hello, there's 40 people on here.
40 people. Sanbonani. Hello, everybody. Okay, we're gonna start in not too long from now. Selengangaki 8 minutes, ne?
8 minutes.
Okay. Usele 3 minutes. Okay, so in the meantime, for those of you that are waiting, we'll start exactly at 6 o'clock. Go grab a glass of water, cup of coffee, get yourself ready. We are going to start in just a few, and hopefully we are going to just take an hour, 30 minutes at most, and that will be the end of our session. So I hope you are waiting in anticipation with me as I have my coffee.
Grant says hi.
Grant.
Yes.
Hi, Grant. Huh? Whilst we're still waiting, hey, I don't know why is it that lives make me feel so nervous. I hope you guys will help me feel a bit calmer today.
I see everyone's comments, they're coming through.
Okay. I hope they're saying something nice that will...
They're saying something nice. They're saying, hi, sir. How are you doing? How was your race?
Oh, how was my race? So I just finished 94.7. That's 97 kilometers, right? Johannesburg cycling race. I should have brought my medal, yes, as a good omen. I posted it for you guys to see so that you know what. If I can finish 97 kilometers, what was a maths exam, eh? What was a maths exam? Organyan Chess.
What was the maths exam?
And I'm with the lady behind the scenes. Ushes is with me.
Hi, everyone.
Come and show your face.
No. Hi, everyone.
You wanna...
They must tell us where they're watching from. That would be cool.
Oh yeah. It would be nice for me to know where are you guys watching from. We wanted to find out what is the level of our reach. Tell us the province, if possible, the town as well, where you are watching from. Yeah, somehow is not make sure about how my position here.
Really?
But it's okay. Let's try and
It's gonna be a long night.
Hey, Kosiam.
Oh, Limpopo, Davidson.
Hala. Shout out to Limpopo. Shout out to Davidson. So the one who is Limpopo, Oh, Limpopo.
Yeah.
Please tell us, if possible, tell us even either the town or the village where you are from, so that I know exactly Kaiko Limpopo.
We have Mpumalanga
Bushbuck Ridge. Hey! I think one of my favorite content creators is from Bushbuck Ridge.
Really?
I won't say whom.
You won't say who? I have because you're my guys, so it's watching.
Osekasi, Soweto. Please tell me where you're from, Soweto. I come from Endofire, MA6, Middlelands Zone 6, for those of you that don't know. That's where I was born. I stayed in Naledi at some point. Please, if you are from Soweto, shout out to you.
So cool. Everyone is from all over. We have Mdeni, so it's Mdeni. We have KZN.
Wasemdeni, Kaslam Lapo. That's my place. That's my place. I used to roll in those streets a lot.
Oh, we have a new member.
Yay!
Sane.
Shout out. Ubani?
Sanelisiwe.
Sanelisiwe.
Mandy.
Okay, let me do this. I'll also try and get onto the live. In fact, let me do this.
Can you give a shout out to Utembi Winnie? She's from Foslo and she is a member.
Shout out to Tembi Winnie, who's just joined as a member onto this channel. Thank you. For those of you that do not know about memberships, please, you can be a member on this channel. One, it helps to support us as a channel. We can do far much more and bring you these lives. But secondly, what it does is that it fosters a sense of community where we can curate content for you that is more specific. Yamo? So if you guys want something more specific, you shout out as a member and say, Uguti, what exactly is it that you'd like to get? Sorry, I seem a bit distracted, but that's because I'm trying to also join from this device. Okay, is not make sure what is happening here. Shares.
Yes.
I'm telling you, just a bit of help.
Okay.
I'm not sure why I'm. This is the live now, no?
Yes, the top one. I think good.
Yeah, what am I Android doing?
Wow. That's one wow.
To those that are using Android, please, no shade, ne? I'm not trying to throw
All
shade.
the shades, take all the shades. What?
Okay, or maybe go back. All right, we've got 1 minute to go. I'm sure you are all seated and ready.
Well, the super chat target. So if we reach the target, you'll do vlogmas for us through December. If we reach our targets.
What's our target? I wasn't told about any target.
Okay, if we reach 700 in super chats.
In super chats.
Yes.
Okay. So apparently our target is 700 in super chats. So super chats, just know that you can maybe throw in a contribution somewhere. And if we reach a target of 700 rands in terms of super chats, then apparently I'll owe you guys a vlogmas of some sort. Huh? Huh? Right. Okay, and there we go. All right. Okay. Right, good afternoon everybody, and thank you so much to all of you for joining us. Today we are going to be going through the live. I seem still a bit awkward, Nyana, because I never really know how to introduce the lives. But it's really such a pleasure to see all of you joining us. I'm with Ushares as well. If you are seeing us, please just let us know where you are watching from. Please also just indicate how you are feeling. It would be nice to engage with you from all ends. So I want to start firstly by saying to all of you, thank you for joining on this live. But secondly, I also want us to have a little bit of a chat, or maybe I can leave that to the end. Ne? Yeah, maybe let's leave that to the end. So I'm going to achieve 3 objectives today. I'm going to go through the maths exam, right? I've chosen this paper from the Free State province, right? This was their 2025 prelim. So I'm going to go through this question paper, not all of it though. So are we going to send a link?
Yes.
Where they can download it? No?
Yes.
Right, so please do note that the link, you can download the question paper from the link that will be provided on the comments section. All right, please just make sure that you have that question paper. So I'm going to go through functions. I'm going to go through calculus, in particular optimization, and also the cubic function. Right, I'm going to ensure that we cover that. And then I think if we have enough time, I can still go through probability, just as a snack, and then just those final words. Now guys, I'm hoping that most of you have gone through the year, you've prepared, you've worked hard and so on, and this time it's your time to shine, right? So without any further ado, I'm going to start with question number 4 from this question paper, and it has that graph. So let's start with this question. Okay, so they say to us, so there we go. So they say to us, we've got the graph below that shows the graph of the function f of x, which is equal to b to the power of x plus c. Right, so that's an exponential graph, all right, albeit it is shifted. I'm not sure if it's just on my side. It shows as though it's hanging. Huh? Okay. Yeah, I don't know, Guti, whether maybe it was bandwidth on my side. No. Okay.
It's just
on my side.
Yeah.
Okay. All right. I think he's on Pazamisa, this thing. Okay. Right, guys, let's go through the question paper. Right. So they say to us, we've got g of x, which is a over x plus p. Now, the one thing that you need to remember, guys, is that remember when it comes to functions, that is the biggest section in your paper 1 in mathematics, right? So remember that you need to do well in this section. So firstly, we know the p value indicates to us what we call in this case the vertical asymptote, right? So that would be our vertical asymptote. And the q value shows us the horizontal asymptote, right? So please keep that in mind. Now, when I look at this graph, here are the two asymptotes. Here's our graph, the hyperbola, right? So there it is. That is the graph of G, right? And I see that I've got an asymptote at x minus 2. And I've got another horizontal asymptote at y is equal to negative 1. Now, guys, I want you to please keep in mind that it means that when it comes to the graph of g of x, right, that's going to be a over, that will be x. Now, note, our vertical asymptote is minus 2. So you always change the sign. So I'm going to say in that case, that would be x plus 2, right? So I change the sign within the equation because it's actually not the asymptote that we are moving, but it is the axis, right? But our q value will remain at minus 1. So that will be minus 1. So that's the horizontal asymptote. That's what the cubic function here too looks like. Okay, but remember, we still don't know what the a value is, right? So they said to you, write down the value of p and q. So p would be equal to, now remember, the notation in this case is very important. So the value of p is equal to 2. And the value of q is equal to negative 1. Note how I've just substituted them into that equation. Remember that the value of p changes sign, right? So that once you get to the equation, it was positive 2, but when you get to the actual asymptote, it becomes negative 2. Right, now, they say to you, determine the equation of g. So we now need to determine the full equation for g. So what I'm going to do is we now need to substitute at least one point that we know of in the graph of G, so that we know which is that point. Happiness, welcome as a member. Siakbona, we see you. Happiness Taki, thank you so much. And please don't forget to also make your contributions in terms of super chats as well, né? Okay, super chats and super stickers.
Yes.
Okay, awesome. We've got a target of 700. Right, so in this case, which point can we take? The point that we're given was that point -6 and 0. So which means when x is -6, the graph becomes 0. The y value becomes 0. So I'm going to say g of -6 is a divided by -6 plus 2, right, minus 1. But remember, this is equal to 0. So now we can work out the a value. So that's a over -3 plus 2 gives us -4. So that's a divided by -4 is equal to, I'm going to take the 1 to the other side, right? And if you look at this, it means that our a value is equal to -4. And this actually does make sense, because when a value is greater than 0, right, our hyperbola is always in the first and in the third quadrant, right? So this is when a is greater than 0. But when a is less than 0, we know that our hyperbola is in the second and in the fourth quadrant. And in this case, we can see that the hyperbola is in the third and the fourth quadrant of your asymptotes, your axes, right? Your shifted axes in this case. Right, so what is the graph of G? So the graph of G of x is equal to -4 divided by x plus 2 minus 1. So that's the full graph of G. Right, and then we go to the next question. Right, they say to us, determine the equation of the inverse of the axis of symmetry of G for m is less than 0. Now remember that the hyperbola has got a axis of symmetry. It's got two axes of symmetry. The one has got a positive gradient, so m is greater than 0. So remember that the axis of symmetry is y is equal to x plus, I'll just say k1. So it has a gradient of 1, right? Now we need to find out what k1 is. But the other axis of symmetry would be y is equal to -x plus, I'll just say k2. But what are they saying to us? They want where the gradient is negative, less than 0. So which means in this case we are interested in the one where m is greater than, less than 0. So that is y is equal to -x plus k2, or you can say -x plus c. Now, how do we get the value of k2, or how do we get the value of c in this case? So we are going to say, right, remember that the axis of symmetry pass through the intersection. So if I'm just indicating it there, they pass through the intersection of our asymptotes, right? So the intersection of our asymptotes, remember that our asymptotes are when x is -2, right? So y is -1. So I'm going to substitute that point there. I'm going to say, well, when x is -2, y is -1. So that's minus -2 plus c. This is equal to -1. And to get the c value, right, we are going to say that's -1, okay? And we've got plus 2 on this side. In fact, just to eliminate confusion, got -1 is equal to 2 plus c. And if we take the 2 to the other side, c is equal to -3, right? So now, which means the graph, now please I want you to note this carefully. So which means the graph of the axis of symmetry, or rather the axis of symmetry, would be y is equal to negative x minus 3. But remember, what did they say to us? They are not looking for the axis of symmetry, they are looking for the inverse of it. Okay? So what do we do to get the inverse? We swap the x and the y value. So I'm going to say, in order for me to have the inverse, in that case, going to say let's swap the x and the y values. So which means that this is going to be x is minus y minus 3. But we need to write it in the form y is equal to. So let's rearrange that. Bring the y, swap the y and the x. So this is the graph of the inverse of the axis of symmetry. So now I'm going to bring the y to the other side and the x on the other side, right? So my y is going to be positive, my x is going to be negative, so I still get minus x minus 3. Let me check quickly to see if I'm not making an error there. Yes, so in this case, note I've just swapped the x and the y value, right? So now when I take y to the other side, it becomes positive, and when I take x to the other side, it becomes negative. So in this case, I've got y is equal to minus x minus 3. That is the equation of the inverse of the axis of symmetry. Please let me know if all right, I see Shem, someone is just complaining with their Wi-Fi. Please just try to adjust your settings so that you can be able to see and view properly. Right, now let's get to the next question. They say to us, write down the equation of the asymptotes of f. So now we are being taken to the other graph. And if you don't mind, guys, I'm just going to erase the other things so that we don't end up with just a lot of clutter there, right? So the graph of f, we've got f of x is equal to b to the power of x plus c, right? But in order for us to be able to know what our graph has, or what our value of b and the value of c is, let's substitute a point that we know of. So definitely this is an exponential graph, and it's this graph over here, right? That's the graph of f. So the graph of f, what are the points that we know? Firstly, we know that it has an asymptote at negative 4. Y is equal to negative 4. That is the line that graph does not go beyond. So already we know what is the value of c, right? They said write down the equation of the asymptote, so it would be y is equal to negative 4, right? So please keep that in mind. Are you writing down notes? Even Shares is listening. Hey, hi guys, we're gonna make a mathematician. Okay, so that means that y is equal to negative 4. So the next one, they say determine the equation of f. Now that I know, we've shifted this graph downwards, the normal exponential graph, by 4 units down, so which means our c value is negative 4. So we can write down the equation as f of x is b to the power of x minus 4. But in order for us to work out the value of b, we'll have to substitute a point so that we know what the value of b is. And you can see, we've got the point p there, which is 2 and 5, right? So when x is 2, so f of 2 would be b to the power of 2, or b squared, right, minus 4 is equal to 5. All right, let's take this to the other side. So I've got b squared is equal to, if we take the 4 to the other side, it becomes a 9. That's 5 plus 4, which gives us 9. And so B is equal to, now remember, when I take the square root in this case, when I take the square root, I can get plus or minus 3, right? But I want you to look at that graph. It is a positive exponential graph. It's an increasing function. So which means the value of B must be a positive value. Now, if it was a graph that was going down like that, then I know that my B value would have been negative 3. But in this case, it means that B is equal to 3. So what's the full equation of F? So F of X would be equal to 3 to the power of X minus 4. Right, so that's the full equation for F. All right, so 4.6. And guys, I want you to realize that you see, you can be able to pick up marks very easily here when you just know what you're doing. And please desist from just looking at higher order questions only, right? Try to also mix up your questions so that you can be able to do just the normal ordinary stuff. And we'll be able to pick up 19 marks from this question, right? So they say to us, determine the equation of h if h of x is equal to f of x plus 4. So h of x is equal to 3 to the power x minus 4, which is f of x, plus 4. So what happens? The 4 and the minus 4 cancel each other out. So what does that mean? It means the graph of h of x is simply 3 to the power of x, right? So now they say to us, determine the inverse, right? H minus 1, okay? The inverse of h in the form y is equal to. So please remember, in this case, you don't need to make it rocket science, right? So when you've got an exponential graph, how do you change that into the inverse? You have log the base of the exponent becomes the base of your logarithm. So that's y is equals to log base 3 of x. Okay, right. For those of you who may be wondering where we get that, so I would have had y is equal to 3 to the power of x. So what you do is you are going to say x is equal to 3 to the power of y. Now, in order for you to bring down the y, you introduce logs on both sides. Okay? And when you introduce logs on both sides, remember that the power, so this would become, right, y log 3, okay, is equal to log x. And if we divide both sides by log 3, you are not really obliged to be able to do this, right? So that is why we end up with y is equal to log base 3 of x. Okay, right, and that's how we end up with that. But just remember, the base of your logarithm, right, the base of your exponent becomes the base of your logarithm. Right, I see there's a question there. It says, what if there is a value of b and c? I'm not really sure what that is in reference to. Leah Kanya, please, if you can just elaborate a little bit more on that question. I'm not sure what you meant about the value of b and c. Right, now finally, they say to us, and I know you guys don't like these kind of questions, ne? They say, for which values of x is f of x greater than g of x? Now, literally, you're going to go to your graphs, okay? And look at the graph of f of x. Where is it physically above the graph of g, right? So if you look at it, over here, right, and I'm trying to just indicate over here, f of x is below g, right? There's your graph of G. It is above the graph of f of x. But you get to this point over here, right? That asymptote. Now, I want you guys to note, this is still the graph of G of x, right? It's over here. All right, so there's the graph of G of x. So initially, before the asymptote, the graph was above. And now, after the asymptote, you can see the graph of G of x is below until they get to be equal at this point over here, right? And then after that, again, the graph of f becomes above the graph of G over there. So we can say that the graph of f, did they say greater than or equal to? Yes, that's great. So that means it's from x is equal to -2. So from that -2 there, which is the asymptote, all the way till infinity, that would be including the value where they are equal, because we also have included where they are equal. So we can say, you can write it as x is an element of -2. Now remember, -2 will be excluded because that's an asymptote. The graph of G is undefined there, right? -2 all the way till infinity. If you want to write it in inequality form, you can just simply say for any value of x is greater than -2. Okay, right. If you wanted to, you could have also just included in this case where they are equal, okay, which is at x is equal to 0. So -2 to 0, okay, including 2 there, and then from 2 all the way to infinity. But I think it only makes sense for you to write it as just one thing. Right, guys, that would have earned you 19 marks. And you can see this question was quite straightforward. No manga business there. Really no tricks in it in the classic sense. Okay, right. So I want us to move on to the next question. So this was not on functions. Right, yeah, I want us to move on to the, yeah, it is on functions. Maybe let me do this so that it just becomes easier. Can I just open it on a different page? I know I had isolated it. Yeah, there it is. All right. So there it is. So this is question 5 from our Free State exam. So they said to us, we've got f of x, which is x squared minus 2x minus 3, and g of x, which is x plus 3. So they said to us, write down the y-intercept of both graphs. Now remember, guys, I want you to keep in mind that when you look at the graph, if you are given the graph of the parabola in standard form like this, right? Note that the constant that you have there, the constant is the last value that you've got in your equation, right? ax squared plus bx plus c. The c value is always your y-intercept. So for the graph of f, the y-intercept is y is equal to -3. And for the graph of G, the y-intercept is +3, that constant as well. Okay, so you've got both of the y-intercepts of your graph. From that, okay, sometimes my pen just misbehaves. Right, now they say to us, sketch the graphs of f of x and the inverse. Oh, Basitsana, welcome. She is our member. Basitsana Vanessa. Thank you so much for joining us as a member. And please just note for all of you, you can join in as a member and you can also make in your contributions on super chats and super stickers. Okay, right. So they said to us sketch the graph of f of x. Now, firstly, we need to get the x-intercept. We already know what the y-intercepts are, and we need to get the turning point, right? So, x-intercept, what are we going to do? We know this is where y is equal to 0, right? Or we can say f of x is equal to 0. So that's going to be x squared minus 2x minus 3 is equal to 0. And please, guys, just know the basics of factorization. It's not necessary for you to use the quadratic formula here, right? So it would be quicker for you to factorize. So what are your factors of 3 such that when you subtract them give you 2? That's 3 and 1. And in this case, you've got 3 being negative and the 1 being positive. So we've got x is equal to 3 or x is equal to negative 1. So those are your x-intercepts, right? Now for your turning point, how do we get our turning point? We know that our turning point, we say the x value of the turning point is minus b over 2a, okay? Right, now remember our b value is negative 2, so that's minus a negative 2 divided by 2 times our a value is 1, so that would be positive 2 over 2, so which means that is equal to 1. Okay, right. And also another way of doing this would be for you to just remember, okay, for you to remember that the midpoint of your x-intercepts is your x value of your turning point. Okay, right. What we sometimes refer to as the axis of symmetry, right? And then how do we get the y value of the turning point? So for the y value of the turning point, we will substitute back into the main equation. So that would be 1 squared minus 2 times 1 minus 3, right? So that would be 1 minus 2 minus 3, which is going to give us negative 4. Right, now guys, I want us to notice in this case, we can draw the graph of f of x. I'm just going to draw a quick sketch. Remember to label your axes, right? So we had minus 1, and we've got positive 3, all right? And our turning point, we said it's at 1 and negative 4. Okay, let's say 1 and negative 4 somewhere there. All right, and then finally, we know that it crosses, our x-intercept is at y is negative 3. Okay, so in essence, this is what your graph kind of looks like. All right, so that's what our graph looks like, and we need to label. So that's going to be at negative 3. Okay, and this is the point 1 and negative 4. So that's the graph of f of x. But remember, they also said we should draw the graph of the inverse of g, right? Now g is y is equal to x plus 3. So what would be the inverse of it? So we need to now swap these around. X is equal to y plus 3. And in this case, when we swap these around, okay, we're going to have y is equal to x minus 3. If I took the 3 to the other side, it becomes negative. So we get y is equal to x minus 3, right? So this is the inverse of the graph of g, right? Now, how do we get there? Which means it's x-intercept. This is where y is equal to 0, right? So you make y 0 is equal to x plus 3, x minus 3 rather. okay? And that means x is equal to 3, right? So that's the first one, x is equal to 3. And then secondly, what do we also have? We want the y-intercept. So the y-intercept, I did say to you that the constant here will be our y-intercept. So our y-intercept will be equal to -3. So graph will be passing through. Y is -3 and x is +3. All right. So I'm going to try and connect the 2 points. Okay, let's just use a different color. Okay, you get the point, ne? All right, let's try and not make you get the point too much. Let's just draw it proper. All right, yeah, I've tried my best. So there is the graph of the inverse of g. So this is g minus 1 of x. This is the inverse of our graph. Okay, and right, so we've drawn the 2 graphs. That's an easy 5 marks that we could have gotten for ourselves. Now they say to us, determine the values of k for which f of x is equal to k will have 2 unequal positive real roots. Now there are 2 ways of doing this, right? The one is to use nature of roots, okay? Roots are unequal, right? That means that delta is greater than 0. But because they said positive roots, which means not only do we just say that delta is greater than 0, but what we need to do is specifically look at the graph. How can we shift the graph? Now notice, what are roots? In this case, the 2 roots that you have, your x-intercept, are such that the one is negative and the other one is positive. But what do they want in our question? They want for our values, right, to have 2 unequal positive roots, okay, positive real roots. So how can I make this graph to have positive real roots? So if I lift the graph up, now please, I want you to listen to me carefully, right? So if I push the graph up, I can end up with my graph looking something like this. You see that if I lift it up by 3 units, that x-intercept can sit at the origin, right? So in that case, that's the beginning of my roots now beginning to be positive. Both of them become positive. So if I can push it up by 3 units, right? But now I cannot push it up to the point where it does this. Okay? Why? Because I am now left with only 1 positive root, right? So which means I would need to lift it up by 3 units, from 3 units upwards, right? And then, but I cannot lift it up by more than 4 units up, which is the value of my turning point. My turning point is at -4. To put it there, I would have lifted it up by 4 units, 4 units going up. So what I'm simply saying, guys, is that we need to make sure that we do not get to a point where it is 4 units up, but we need to lift it up by 3 units. So, which means, now remember, f of x minus k was the equation. So f of x minus k is equal to 0. Notice that this is minus k, right? So, which means minus k must be greater than, or rather must be greater than 3. I've lifted it up by 3 units. but it must not be greater than 4. Okay, right. It must be less than 4. So this is minus k. So which means that when we flip this around, multiply by the negative, please remember the inequalities change sign. So which means that negative 3, right? That would be k. Now it is facing to the other side. So that's minus 4. Or we can write it the other way around and say k must be greater than negative 4, but less than negative 3. So that's another way of writing it down. So please remember that they did express this as f of x is equal to k. So you need to get it first into standard form by writing it as f of x minus k. Right, I hope that is clear, guys. That is you doing this by inspection. It would not suffice for you to only do it using nature of roots in this case. So you just needed to do it by inspection. All right, now let's look at this last one on this question 5. And I know you guys love these kind of questions. So they say to us, for which values of x, right, is f prime of x. Now remember, when we say f prime, this is the gradient. Okay, so I want to write this down. This is the gradient of the graph. Okay, and when we say f double prime, we are talking about the concavity of the graph. All right, so f double prime in this case. Now I want you to think about it. No matter how much you can look at it, this is a concave up graph. So which means the concavity of this graph is always positive. Let me just show you. If we take the derivative there, you will have 2x minus 2. But if you take the derivative of the derivative, you are only left with 2. So which means its concavity is always positive. It's always concave up, right? So now, which means this guy here is always positive, right? So they are asking us for which value of x is the gradient multiplied by, in this case, the concavity, right, being upwards, greater or equal to 0. Now, please stay with me. If I want something to be greater than 0, if I want a product to be greater than 0, if I have a multiplied by b greater than 0, right, or greater or equal to 0. Now, please, I want you to notice this. The product of two things to be positive, it means both must be positive, right? Positive times a positive gives me a positive. Or both must be negative, right? Now, I want you to note, in this case, there is no way f double prime is positive, is negative. It is always positive, right? Now, for us to end up with a positive answer, it means that where f prime must also be positive, right? Where the gradient is positive. It means this graph of ours must be an increasing function. Now, let's go to it. Where is the graph increasing? Right, I'm going to remove the green ones and go back to the original graphs. Now, please remember, when we're talking about increasing, we're talking about as we move towards the right. So, where is the graph increasing? From the turning point, from the turning point all the way up until infinity, this graph of ours is increasing. So where that statement is true, all right, from x, okay, so it will be true for x is greater or equal to, now note in this case, the gradient was equal to 0 at the turning point, so I'm including it because they said greater or equal to. So this will be x is greater than or equal to 1. This was where our turning point is. Or if you wanted to write it in elemental form, you can say where x is an element of 1 included all the way till infinity. That is where that statement is, where it holds true. Okay, and again, guys, I find that some of you still struggle a bit with these kind of questions. If it is that as you are watching this, I hope that you are able at least to follow what I'm doing and to follow the rationale. I've published quite some content on explaining what exactly this means. Right, if you're struggling with it and you are panicking about tomorrow, please don't stress too much about it. These are the application type questions. I call them synthesis type questions, right? Where you are taking something and you're putting it in a new situation, right? Just maybe pass this question for now, and then you'll come back to it at the end once you've answered all the other things. Otherwise, you find yourself just wasting time and not being able to finish at the end of the day. Okay, so I think we'll close it out there in terms of functions, right? Okay, so there's a question.
There's some students who are asking about question 5.3, if you can just
explain again.
Yeah, and you mentioned the second method.
I mentioned the second method. I was talking about nature of roots, but it's not going to work.
Okay.
Yeah. So the second method in 5.3 would not work. You'd need to do it by inspection. I'll show you how it works in terms of nature of roots. Let me just quickly just erase and try to re-explain question 5.3. Right, now question 5.3, just to make it make sense again. So you are given the equation, all right? You're given the equation, so, all right, there's my pen acting up again. All right, there we go. So you're given the equation f of x is equal to k. So firstly, I'm going to write it as f of x minus k is equal to 0, right? So what does the minus k mean? It means you're taking the graph of f of x, you are either shifting it up or you are shifting it down for it to meet the conditions that you want. Now, what are those conditions? The conditions is that it must have two unequal positive real roots. Okay? Now let's go back to our graph, right? When you look at this graph, it has two roots at the moment. The one root is negative and the other root is positive. Let me just show the roots, right? So the one, so the one root is negative and the other one is positive, right? So here's your roots, -1 and +3, okay? Now, what do you want? You want your graph, the same graph. We are going to either shift it up or shift it down so that the roots are only positive. Okay. Now note, if I shift the graph down, what simply happens is this. Do you see? The roots still remain, the one is negative and the one is positive. But when you shift the graph up, the y-intercept there can sit like this. Shez, tell me, does that make sense?
Yes.
Okay. You can take this graph and push it up so that this point here is now sitting at that point, at the origin. But by how many units would you have moved it up? It would have been by 3 units. Because remember, it was at -3, but you now want it to sit at 0. So you would have moved the graph up by 3 units. Now guys, I want you to please listen carefully. If I move it up by 3 units, right? What does it mean? It means now I've got 2 of my intercepts, right? Where are my intercepts? My one intercept is at 0, the other one is positive, right? 0 and another positive one. But what did they say? They said they wanted the roots to be both positive. Now, if I can just shift it up again, now think about it. If I shift it up again, what happens all of a sudden? My roots are no longer one at 0, one positive, but both of them are now positive. Which means if I elevate it anywhere by more than 3, right? Both roots now start being positive. Okay? There's my one root, there's my other root. So which means I need to shift the graph up by 3 units, more than 3 units. But, please, I want you to see this. But if I now elevate it to the point where the turning point is the x-axis, that's not what I want. Because then it means that it no longer has 2 roots, but it has only 1 root. And the instruction was clear. They said there must be 2, there must be real roots, and they must be positive. So you cannot lift it up. Now think about it. My turning point was at -4, right? To get it to be at 0, I need to push the graph up by 4 units. So this shift here, which is -x, right, represents a vertical shift. So which means -x must be greater than -3. I must push it up, greater than 3, push it up by 3 units, but I can't push it up by more than 4 units because I start having 1 root. Okay, -x must be greater than 3 and less than 4. But remember, I can't leave it as -x. I multiply by the negative, so that's where I have -3. It now faces the other direction. Remember, when I multiply by the negative, the inequality changes sign. So in this case, my inequality faces that way. But for me to write it in a logical manner, -4 is smaller than -3, so I need to flip it the other way around, and that's why I write it as k is greater than -4, okay, and less than -3. It's still the same thing, just flipped the other way around. Okay, right. I hope that makes sense. As I've repeated it, I hope that you guys do get this. All right, now, are we still good?
Yeah.
No other question? Is it right?
We're moving swiftly.
All right, awesome stuff. All right, please, I hope you like. For those of you that are unsubscribed, make sure that you hit that subscribe button. I know that does not include any of you. Tell all your friends. Okay, right, now let's go to the calculus part.
Can you start with financial maths?
Can we start with financial maths? Okay, I wasn't going to cover it now, but
Okay, let's start with calculus.
you know, my issue is if Sizo include, we may not. Can I start with the calculus and then we'll see if we have enough time?
Yes.
Okay, all right. There was a question on financial maths?
A lot.
You. Okay. Sure.
Let's push calculus.
Okay.
And then what we don't cover, we'll link the links to the videos.
To the videos. Okay, that's fine. That's fine. Okay. Right, now let's go to question number 8, which is on the cubic function. As I did say, I'm going to cover a lot of functions, guys. And then I want to cover optimization as well. Yeah, let's go for it. So they say to us, we've got the equation of the cubic function. Okay, I just want to make sure that it's as visible as possible. Right. They say the equation of the cubic function f is given by f of x, which is x minus 1, into x squared minus 4x plus 4. I like it when they do that, because what they have given to me is the factor there, right? And they have also given me the quotient as well. So they've written it in what we call the factor and remainder theorem, right? So in this case, this is the factor, and that is the quotient in that case. And we know that once you've multiplied all of that, it gives us the product of those, which is that cubic expression over there. Now they say to us, calculate the coordinates of the turning point of f. Right, what do we know about the turning point? We know that the derivative, right, so we're going to say f of x is equal to x cubed. Right, I just want to turn this thing off. Right, so the derivative, so that's minus 5x squared plus 8x minus 4. Right. Okay, so how do I get the turning point? I take the derivative and make it equal to 0, right? So which means, in this case, our derivative, that's going to be 3x squared minus 10x plus 8 is equal to 0. Now, some of you have got powerful calculators that are able to give us you know, just those, I mean, the factors in this case. So you can do that. In my case, I'm just going to use the old method. So let's see. There we go. So 3 times 2 gives us 6. 4 times 1 gives us 4. And both of those do give us 10. So which means those are my factors in that case. Right, so which means I've got 3x and 4. I've got x and 2. And this is equal to 0. Now, this is negative and negative, right? So I want you guys to please note in this case that it means if I'm solving for this, that x is equal to 4 over 3, right? Or x is equal to 2. And please forgive me, guys, I'm going to be really fast at this because I'm assuming there are certain things that by now you should be able to just get. Okay, right, so I factorized this, made it equal to 0, and in this case it means that x is equal to 4 over 3 or x is equal to 2. So those are the x values of your turning points. Now, how do I get the y values of my turning points? So we're going to substitute for those. They set the coordinates, né? Right. So I'm going to say f of 4 over 3. That's 4 over 3 cubed minus 5 times 4 over 3 squared plus 8 times 4 over 3 minus 4. I wish, Shez, are you able to calculate this? The other one is a 2. That's what 2 Shez.
I'm looking at the comments. What am I calculating?
No, it's okay. Okay, so ngenzela ukuthi sothola the values as quickly as we can. So I've got 4 over 3, right? So that's cubed. That's minus 5 and 4 over 3. Okay, and that's squared. That's plus 8 times 4 over 3. And that is minus 4. All right, I get a value 4 over 27. Please, if just verify for me if that value is correct. It would help for me if I could. It's possible that I might make a mistake. All right, so I'm going to take the next one again, which is 2. So that's 2 cubed.
Yes, correct.
Okay. Minus 5 times 2 squared. Hey guys, Ushes is now a mathematician. Right, and the other value is at 0. And in fact, we could have actually guessed that. Now please, I want you to note, when we took the x-intercept, when we took that there, you can see, Guti, this becomes a perfect square. So this would be x minus 1 into x minus 2 all squared. And guys, I just want you to note, when you find one of those factors being squared, then it means it's not only just a turning point, but it is also the x-intercept. Okay, but we'll get to that in just a little while. Right, so we were looking for the coordinates of the turning point. So the coordinates of our turning point in this case, so our turning points would be at x is 4 over 3 and y is 4 over 27. The other one would be at 2 and 0. Okay, right, well, and then I knew they were going to get us to this. Sketch the graph of f clearly, indicating the intercepts with the axes and the turning points. So, what else do we need for this graph? We need the x-intercepts. So, x-intercepts. But remember, this is where f of x is equal to 0. But they have already kind of factorized the graph for us. That's x minus 1. And it was x squared minus 4x plus 4, if I remember correctly. Yep. Right? And this is equal to 0. So, that's x minus 1 into x minus 2 into x minus 2. So that's x minus 2 all squared, right? So which means our x-intercept would be at x is equal to 1 or at x is equal to 2, all right? So those are the x-intercepts. And now, finally, guys, the y-intercept, right? That is the constant term in our graph. So our y-intercept must be at negative 4, right? So y-intercept is f, where x is equal to 0, and this is equal to negative 4. Now let's try and draw the graph. Please remember to label your axes when you are asked to draw the graph. Okay? So firstly, I note that my a value is positive. So remember, guys, that when a, the coefficient of our x cubed term, is greater than 0, then it tells me this is the shape of our graph, right? It's going to start as an increasing function. So it starts with a local maximum and then a minimum. But when our a value is less than 0, it means this would be the shape of the graph. Okay, right. So firstly, where are my turning points? We said 4 over 3 and 4 over 27. So 1 and 1 over 3, and we've got 4 over 27. Okay, and it crosses the y-intercept at negative 4. And please, guys, this graph is not going to be very accurate. I'm just going to try and represent it as best as I can. Our x-intercept was at 1 and 2, okay? So the x-intercept is at 1, the other one is at 2, okay? And right, the other turning point is at 2 and 0 as well. So I'm going to just try to draw this graph. I should have made it a little bit wider just for me to be able, okay, if you don't mind, I'm just going to do this. Okay, I'll rather label the points afterwards. So this would have been the point. Okay, so this would be the x-intercept, which is at 1. This is the turning point, which is 4 over 3 and 4 over 27. This is the other turning point, which is 2 and 0. Okay, and what else? This is minus 4, the y-intercept, and this is what our graph would look like. Okay, right, this is what our cubic function would look like. All right, so I drew it this way so that at least it's a bit bigger. All right, we can be able to see what our graph looks like. Now finally, let's answer the question that they are asking us. They say to us, for which values of x is f prime x greater than 0? So please remember, we said this represents the gradient of the graph, right? Where is this graph going uphill? I always use this as, where is my graph going uphill as I move towards the right? Now think about it. Where is it going uphill? It's going uphill over here. Right? It's going uphill over there. Right? And then it goes uphill over there. So it's from negative infinity until the turning point, the first turning point, which is 4 over 3. And it's from the other turning point, 2, right? And all the way till infinity, it is going uphill at those points. So let's write down the solution. So this is at x is an element of negative infinity, okay, till 4 over 3, but that is going to be excluded, all right, because that's the turning point, right? The derivative at the turning point is equal to 0, and they only said greater than. And then again, it will be from 2 all the way till infinity, right? So in that case, from the other turning point all the way till infinity, our graph is going uphill. All right, and then finally, they say, where is x multiplied by f prime? So remember, any time I've got a product of two things, now they are saying to me, where is the product less than 0? Stay with me. Now, when do I have a product that is greater than, that is less than 0? Either one of two ways. When x is positive, then it means that my derivative should be negative. So I am asking myself the question, where on the positive x values, right? On the positive x values, where is the derivative going downhill, right? So on the positive x values, so meaning on the right side of the graph, when am I going downhill? Do you see? Right. Where's that happening on our graph? On the positive side, so meaning for all values of x greater than 0, right? Meaning it is on the right side of my graph, on this side. Where is the graph going downhill? Now I want you to please note, where's our graph going downhill? Okay, I'm just going to indicate it with that turquoise color. All right, I don't know why it does this. Right, where's our graph going downhill? Between, can you guys see? Our graph is going downhill between those turning points. So which means it's between 4/3 as well as 2. The x value is positive, but the gradient is negative, right? So the product would be negative. So I'm going to write down that solution, but we'll come back to it. So x element of 4/3 all the way till 2. Okay? Right. But again, we can flip the script around and say when x is negative, so which means we are looking at the left-hand side of the graph, where is the derivative positive? Where is the graph going? Uphill. Now, I want us to see there. Where's our graph? On the negative side, which means we're looking on this side of the graph. Where is the graph going uphill? Well, in this case, all the way from negative infinity up until we get to 0, right? The graph is going uphill. As you move towards the right, the graph is going up, right? So x is negative, but the graph, the gradient is positive. So in that case, from negative infinity all the way till 0. Okay, so which means we've got another solution. X is an element of negative infinity to 0. Now please, when we write down the solution here, we write it down as just one thing, right? So I'm going to say one expression. X is an element, you always write it in ascending order. So x is an element of negative infinity till 0. You do not include 0 in this case. Negative infinity you always exclude. But again, from 4/3 all the way up until 2. So that is our final solution. So this is where the graph fits that description. I hope that is clear, guys. I don't know why they gave this 2 marks. It is a bit of work, but I suppose for those of you who may be struggling a bit, that's not really too bad, you know, if you're going to lose those marks. All right. Let's see. Say why not to 1? Suddenly Siwe, I'm not sure what are you talking about this graph here?
Why 8.2, question 8.2.
8.2.
She's asking why is it not 1?
8.2, when we were sketching the graph. Why is it not 1? Where? Okay. All right, Suddenly Siwe, I'm not sure I understand your question quite clearly. If you can, maybe just rephrase so that I can be able to attend to it. Okay, right. So let's see. Optimization quickly, right? And then let's see if we can get to financial maths.
Okay. She just said the second part. Why not from negative infinity to 1?
Why not from negative infinity to 1? Oh, okay, okay. I think she's asking about this portion. Now, because remember, so we were saying where the graph is negative. Remember, when we're looking at that condition, we're saying, look at this. I want where x values are negative. Where are x values negative? Right? X values are negative from here until 0. Right? From that point, your x values start becoming positive. So that's the reason why we are not going all the way till 1, because from that y-intercept, your x values start becoming positive. I hope I'm clear about that. Ne? So your x values are negative here, and your gradient is positive. But from x is equal to 0, then your x become positive, even though your gradient is still positive, but your x values are positive in that respect. Okay, I hope Sanelisiwe, I've got your question correct. Ne? All right, now let's quickly go into that optimization thing. All right, very quickly. Right, now they say to us we've got a cylinder. So instead of ukwenza no, I was saying, because we said we were going to do probability. So I can skip that and do finance instead.
Let's ask them in the chat and then we'll get back to you.
Okay, all right. So please just comment. Do you want me to do probability or do you want me to do finance? I can do either one. I'm looking at our time, so I won't be able to do both, but I can at least be able to do one or the other. The question in probability here had to do with the Venn diagram. It's a 3-set Venn diagram, so I just wanted you to see how to plot that. Okay, it requires We'll
run a poll and then we'll see.
Okay, run a poll quickly and then we'll be able to determine. All right, guys, we'll run a poll because I see, I think the majority is.
Probably.
Oh gosh. Okay, let's try, guys. Okay, so they said to us a cylinder closed at both ends is to have a volume of 2000 pi. So the volume of the cylinder is 2000 pi. What should be its dimensions? What should be its dimensions be if the surface area of the cylinder is to be as small as possible? Right. Now, I want you guys to please note, there are two things that we spoke about here, right? We spoke about the volume. So volume, this is not too visible. So volume is equal to, remember, that's the area of the base, and the cylinder has got a base, so that's the area of base multiplied by the height. But what's our base? It's a circle, right? So that would be pi r squared multiplied by the height. Okay? So that's our volume. But what did they say? They said this is equal to 2000 pi. So what you normally do in optimization is we're going to have to eliminate one of the variables. In this case, I'm going to eliminate the height in this case. So I'm going to say, all right, so we've got pi r squared times h is 2000 pi. So let me just remove this. Okay, so I'm going to divide by pi r squared divided by pi r squared. Okay, that, so h, okay, pi and pi cancel, so h is equal to 2000 divided by r squared. If you wanted to write it in another format, it would be 2000 r to the power minus 2. Okay, so that's the value of h. But now, I want you guys to please note, what did they say? What should be the dimensions of the surface area, of the cylinder? Rather, what should its dimensions be if the surface area is to be as small as possible? Now, when we're looking at a cylinder, right, they did indicate to us that that cylinder is closed on both ends. So you've got a circle that's closing here, you've got a circle that's closing there, and you've got the rest of the cylinder, okay? So, which means surface area, right, would be 2 times the area of the circle, so 2 times pi r squared, right? So it's the 2 circles, plus, now for the surrounding part of your cylinder, this would be 2 pi r, right? The circumference of the circle multiplied by the height. So multiplied by h. So surface area in terms of r would be 2 pi r squared plus 2 pi r. Now remember, what is our height? We said that's 2000 divided by r squared. So this would give us, okay, that's 2 pi r squared plus, now I'm going to try and make this as simple as possible. So that's going to be 4000. Now note in this case, the r there cancels out with one of the r's. So I've got 4000 multiplied by pi divided by r. Or I can write this as r to the power minus 1. That's the same as saying divided by r, right? So that I can be able to take the derivative. Now, what are we trying to do? We're trying to minimize the surface area, right? So in order for us to minimize, we're going to take the derivative of the surface area with respect to r, right? So which means we're going to have 4 pi r minus, so remember, it's jumped down, 4000 times negative 1, that's minus 4000 pi, that's r to the power minus 2. So remember, it's minus 1, right? And the derivative is equal to 0. So now we can work out what the value of r is. So we're going to say this is 4 pi r is equal to 4000 pi, right, divided by r squared. So to make it easier, I've written it as 4000 pi divided by r squared instead of r minus 2 to the power minus 2. Those are the laws of exponents, right? And then what we can do, guys, is just to cross multiply in this case. So I've got 4 pi r cubed is equal to 4000 pi, right? And I can divide by 4 pi. 4 pi. So r cubed, right? Pi divided by pi, that's 1. That's 4000 divided by 4 is 1000. So which means r cubed is equal to 1000. So r is the cube root of 1000, and that would give me 10. Okay. Now remember, it means that our r value has to be 10 meters in this case, because our dimensions were given to us in meters. Okay. Right. Hey, Spamanda says finance, 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 finance. Okay, right. So we took the cube root and we got that to be equal to 10. All right, and then finally, we are now going to get the value of h. And so what do we do? To get the value of h, we are just simply going to substitute that back into that equation. We said h is equal to 2000, right, over r squared. So this is divided by 10 squared. Okay, so that's divided by 100. What's the height? Okay, and that h is equal to 20 meters. All right, I hope that all of us are well. I think that is it. Yay! But if fiance is easy. Okay, I think they wanted to say finance is easy. Hey, I wonder, who's thinking about fiancés? Okay, right, so h is 20 meters. Right, so let's do this, guys. We are left with just a few minutes, right? So okay, there's this question on the fundamental counting principle. Okay, let me do this. I'll quickly go through this, just the construction of it, okay? And then I'll go to...
We 50-50 on finances or probability, but you want to do the counting principles first?
Should I do counting principles?
No, I'm asking.
Okay, let me do the three thing on okay. Yeah, guys, we're 50-50 on both. Maybe I can just take you through what to do on the finance question. But finally, so they say to us we've got a survey that was conducted to 100 grade 12 learners of Linakeng Technical High School regarding their preference for the following subjects: mathematics, physical science, and life sciences. Okay, so the following was revealed. Now, guys, when you're going to draw or construct this three-set Venn diagram, the mistake that some of you make is that even if the information is not necessarily complete, right? Be careful when they tell you something about, let's say, X number of learners like mathematics, because that does not say they like mathematics only, right? It simply just says they like mathematics. They could like mathematics and physical science, for instance. Okay, right, let's go through this very quickly. So we know that our sample space in this case will be 100. They say 8 learners prefer all 3 subjects. Now, which means in this case, I can automatically say, well, I know that 8 would be the intersection. Okay, it's maths, P and L. So let's say M, P, as well as L, right? And then they say 12 prefer mathematics and physical science. Okay? So mathematics and physical science. So now, in this case, that 12 could also include, okay, could also include those that like mathematics, physical science, as well as, what's the other one? Life sciences, right? So I'll skip that for now. I'll come back to it in a bit, right? Let me work with information that is really specific that I know. So I'll come back to this. Okay? And then they say 5 prefer physical science and life sciences, but not mathematics. Do you see? They're very specific on that one, right? They're saying to me, I've got 5 that prefer physics and life science. Okay? But they don't like mathematics. So they're over here. They are very specific on those ones, right? And then they say X number of learners, okay, prefer mathematics and life science, but not physical science. So it's maths, life science, and not physics. Maths and life science, but not physics. So that would be the X amount over there, right? It's the intersection between maths and life science in that case. Okay. Right. But they do not like mathematics, right? They were specific again on that one. And then they say to us 61 prefer mathematics. Okay. Right. So I'm going to show you just how to construct this, and then you can do the rest of it for yourself. Right. 61 prefer mathematics. Now, do you see how that's 61? All right. So it's everything on mathematics would be 61, right? Now, we still have not answered the question of those 12, if whether they just like maths and physical science in this case. Now, if I look at maths and physical science, now I'm going to go back to that. I just want to try and rush a little bit. Right, so we've got the 61 that prefer maths. We've got the 19 that prefer science. Got the 73 that prefer life sciences. And we've got 14 that prefer none of the 3 subjects. So we know we've got the 14 that sticks over there. Now, guys, I want us to quickly address the issue of the one that I've put a star on. They said to us 12 prefer maths and physical science, but they didn't tell us that it's exclusively just maths and physical science. So that is also inclusive. So where's maths and physical science? It's everything here. So it means it also includes those who also like life science. So which means I'm going to say, well, it's the 12 minus the 8 that I've already included over here. So which means this number must be 4. So that the 4 plus the 8 give me the 12. I hope that's clear. Now, again, 61 prefer maths. So which means everything over maths. So we're going to come to this part here. So which means 4 plus 8, right, plus x, plus, I'm going to call this m over here, plus m is equal to 61. So what would be maths only in that case? Maths only would be 61 minus the 12 minus the x. What's 61 minus 12? That's 49. So that's 49 minus x. So which means over here, I would have 49 minus x. And then they said 19 prefer physical science. So again, it's the 4 plus the 8 plus the 5. Okay, it's the 4, it's the 8, it's the 5, plus this p. So 4 plus 8 plus the 5 plus p is equal to 19. So what would be physical science only, right? So that's going to be, what's 12 plus 5? That's 17. So p is equals to 2. So there's only 2 people that like science only. Shame on the learners of the school. Okay, and then finally, we had 73 that prefer life science. So, which means it's going to be 8 plus the 5. It's the 8, it's the 5, it's the x, and L. So 8 plus 5 plus x plus L is equal to 73. 73. So L would be 73 minus 13. That's 60, ne? Yeah. So that's 60 minus x. Okay, so which means for life science only, we are going to have 60 minus x. Okay, so now please remember, guys, that's how you construct this. Now, if they say to us, calculate the value of x, which means all you are simply going to do is add everything up. So which means 49 minus x plus 4 plus 2 plus x plus 8 plus 5 plus 60 minus x plus 14 should give us the total number of learners at the school, which is 100. So that is how you are going to calculate the value of x. And if they say to us, calculate the probability that a learner chosen randomly prefers only one subject, okay? Only one subject. Now, where are the only one subject learners, right? I want you to note, now you know the value of x, so it would means it would be the 60 minus x, it would be the 49 minus x, it would be the 2, and remember you divide that by 100 to get the probability thereof. Okay, so that's how you'd go about that question. Hi. Guys, I'd love to conclude right now. I really would have loved for us to go through as much as we possibly can, but maybe let me just conclude with my last remarks. Unfortunately, we won't get to financial maths, but we have covered quite a bit of content. Hey, Shez is not impressed. Do you want me to do at least one?
Just one question.
Just one question.
Yes.
Okay. All right. That's fine. Shez is twisting my arm and saying we should do at least one question on financial maths. All right. Maybe let me do this. Yeah. Okay. Let me see which of the questions do I think would be. All right, maybe let me look at 6.2 as well as 6.3. I think 6.1 you can be able to answer that quite straightforward. Let's see. They say on the 1st of June 2024, a bank granted Utabiso a loan of 250,000 at an interest rate of 15% per annum, compounded monthly. So that's important. It's compounded on a monthly basis, right? And we know what our interest rate is, right? To buy a car, Tabiso agreed to repay the loan in installments commencing on the 1st of June, right? On the 1st of July, rather, and ending 4 years later. So which means that Tabiso is going to pay over a period of 4 years. However, Tabiso was unable to make the first 2 installments and only commenced with monthly installments on the 1st of September. Okay? Right. Calculate the amount Tabiso owed the bank on the 1st of August, a month before he paid his first monthly installments. Now, I want you guys to please note in this case. So, this is what we call a deferred annuity. You were supposed to pay, but you did not start paying. So what's going to happen? And this is very important for the future value formula in terms of what I am going to instruct you, right? So here's Tabiso taking a loan over here, right? But what does Tabiso do? Right, let's say here's supposed to be first payment. Okay, I'm going to say this is T0, this is T1, and this is T2, right? So what happened with Tabiso? Gonya, how many months did he skip? However, he was unable to make the first 2, okay? Right, so what's going to happen? for those 2 months, that amount sitting inside the account is going to accumulate interest. All right? So what's going to happen to the 250,000? It is going to accumulate interest for the first 2 months. Okay? So which means we're going to say A is equals to P into 1 plus I over M times N. So that's 250,000. Okay? That's 1 plus our interest rate was at 15%. So that's 0.15. That's over 100, right? And that is divided by, now remember that interest is compounded monthly, so that is divided by 12. But how many months did he skip payment? He skipped payment for 2 months. So our N represents the number of the payment period in this case for which that annuity was deferred. Right, so you'll get that amount over there. Okay, yeah guys, I'm rushing manje. So that's 1 plus 0.15 over 12, and this is yx2. Okay, so which means when the amount was sitting in the account, it accumulated to 256,289 rand and 6 cents. Now please guys, note that in financial maths you can only round off to 2 decimal places. And why is that? Because the highest amount or the lowest amount of money that we can have are cents, right? So in that case, that's the amount that would have accumulated. Now quickly, they said having paid his first monthly installment on the 1st of September. Now remember, from the 1st of July, right, all the way till 1st of August, the money set in the account and accumulated interest, right? And now they're saying having having paid his first monthly installment on the 1st of September 2024, Tabiso will still pay his last installment on the 1st of June, calculate his monthly installments. Now guys, it's important. Please, I want you guys to note. Now we are using the future value annuity. Anytime that you have an amount, present value. No, did I say future value? Did I say future value? Okay, sorry. We're using the present value annuity. Every time I have an amount now, right, that I need to pay off, right, in this I'm going to use the present value annuity. Now, please, I want you to note this. Every time I'm using present value annuity, you need to have that month's gap, right? So what happened with Utabiso is that here's the amount sitting up until August. This is in August, right? But what happened? There's a gap, then he starts paying in September, right? Okay, so then he starts paying in September. So the first payment starts coming in September, okay? That's the first amount that he's going to then start paying. Now, please, I want you guys to note, right? How long does he have to be able to pay off the amount, right? Remember, how many months have I missed now? I have missed the first 2 months, and now I am going to pay over, right, the remaining period, which means it's 4 years. So how many months is that? That's 12 times 4, that's 48, right? Minus those 2 months. Okay, so that's 48 minus the 2 months. Because remember, in the 3rd month, which is September, only then does he start paying off the amount. So please note, you're going to use the present value annuity, right? That's x into, that's 1 minus 1 plus I minus n divided by I. Okay, our present value in this case, that's 256,289.06. All right. And right. So we want to find out the value of x. Okay, so that's 0.15 over 12. But now I want you to note the repayment period in this case, that's the 48 months that we had, right? But we lost the 2 months wherein we were not paying, and on the third month we started paying. So which means in this case we would have 48 minus the 2, so that would be over the 46 months. Right, sorry, that's minus 46. Okay, and this is divided by, again, 0.15 over 12. And please, guys, just note, I'm not going to complete this, right? You can work it out. You look unimpressed.
No, I'm impressed.
Okay, I'm not going to complete this for the sake of our time, so that at least I'm able to also get to the last question, right? It is worth 6 marks, so it is quite probably some work for us to do. Right, now let's get to the next one. So they say to us, X rents is invested into an account at an interest of 12% per annum, compounded monthly. 3 years later, 2X rents is deposited in the same account. After 7 years, there is 276 rand, 76,000. Why does it look like Tabiso's money? Anyway, after 7 years, there is that amount in the account. Determine how much money was invested at the beginning. Ooh, this is quite an interesting question. Right. Now, please, I want you to note, guys, we're going to start having our timeline. It's 7 years, right? But in this case, what happens within the 7 years? Right, firstly, we deposited an amount of X. Okay? So let's say year 1, year 2, 3, 4, 5, 6, and 7. 5, 6, and 7. Right. Now, please, I want you to note. So we are depositing an amount of X, right? But for how long is that amount going to stay in our account? The X amount is going to stay for the duration of the 7 years, right? So this will stay for the duration of the 7 years. Stay with me on this one. But then we've got another amount that we deposited, which was 2x. When did we deposit? 3 years later. Okay? So at year number 3, right, we are going to now deposit 2x. How long is it going to stay? It's going to stay for 4 years in the account, right? But cumulatively, both these amounts are going to accumulate into that amount. Now, please, I want you to note, how am I going to do this? So it's going to be the first deposit, okay? So I'm going to write that in blue, right? So it's going to be A1, right? Which is P into 1 plus the interest rate was 12%, that's 0.12. They said it is compounded monthly, okay? So that's divided by 12. Right. But now what is the period? It would be the 7 years multiplied by 12. So it stayed for the full 7 years. Right? But what is our p-value? Our p-value is x. And then we've got the accumulated amount number 2. What's the amount? It's 2x amount, right? That's 1 plus, again, 0.12 divided by 12. But how long did this amount stay in the account? It stayed in the account for 4 years. Remember, it was deposited 3 years later. So this would be 4 years. That's the time remaining for it to mature. So that's 4 times 12. And in this case, both of these amounts are going to be taken and added together, and they are going to give us an amount of 256,000. So we need to add these, and in this case, once we add them together, they both give us 276,558,075. Okay, so our task was to get the value of x. Do you want me to get the value of x?
Please.
Okay. Eish. Yazi wena nabashana bakho. Okay. Right, and I'm concluding on this, guys. I hope that you get this. Right, so that's x into, that's 1 plus 0.12 over 12. I think this will be 0.1. Okay, what's 7? Seven times 12. That's 84 plus, again, 2x into 1 plus 0.12 over 12 gives me 0.1. Guys, please don't be surprised where does the 0.1 come from. Né? And 4 times 12, that is 48. And this would give me 276,558.75. Now, please, I want you to note, all that's left for us to do is to just get x out. Right? So, which means you've got 1 plus 0.1 to the power 84 plus 2. Please remember we have no coefficient of 2 there. That's 1 plus 0.1 to the power 48, right, is equal to that entire amount, 276,558.75. And to get the value of x, all I am simply going to do, guys, is that I am going to divide by this entire expression. So please, if you don't mind, I'm going to do it on my calculator. I'll take that entire amount, 276,558.75. And I am dividing it. Okay, let me do this. Divided by. I'm going to open brackets and say this is 1 plus 0.1. Okay. Yx to the power of 84 plus 2 times 1 plus 0.1, again yx to the power of 48, and I close those brackets. Okay, Um, No, I'm getting answers that are weird here. Must have done something incorrect. I get a value of 80. Oh, yeah. Sorry. I said 0.1 instead of 0.01. Thank you so much for that. Ne? Thank you for that. Yabon? Yeah, because I'm rushing, manje. I'm making errors. Okay, 0.01. Thank you for that, guys. So that would be 0.01. Yeah, no wonder I was getting those weird values. 0.01. Okay. All right. So if I go back to my calculation, 0.01, and that's 0.01. Yes, there we are. I found that the value of x and to the dot, 50,000. So which means the amount that was deposited, initial amount that was deposited is 50,000 rands. Thank you so much for the help, guys. I had done something wrong, Lana. I said 0.12 divided by 12. I said that's 0.1 instead of 0.01. All right, and that brings us to the end, and that's how you would have gotten your value. Yeah! Mara, guys, you owe me for this extra 30 minutes.
Yes.
Huh?
Big
So,
time.
just last minute advice for tomorrow. Please keep it together, guys. Here's my advice to you. As I said, if perhaps that you find that you're still having a bit of a challenge, start with the sections that you are confident in. You are welcome. You're welcome. Thank you so much. Thank you. I'm seeing all the love. Thank you. And thank you to Shares, who's assisting me. Aufuni, still to show your face. Was it?
Okay.
Okay. And yeah, so I'm trying to say, guys, please keep it together for tomorrow. Just do the best that you can. To those of you that may be doing well, please don't be so overconfident to the point where you make silly mistakes. Okay? Keep it together. Keep your composure. Start with the sections that you love and that you know you can do well in, and then build your confidence up. All right? Please don't work throughout the night unless you are one of those people that thrive at night. But please, if you are like me who likes to work in the morning and prefer to sleep at night, please make sure that you get a good night's rest. Don't work throughout the night and exhaust yourself. I was telling Shares about what they call taper week, right? So, which means just prior to a big event, what you do is you try and minimize the activity that you do, okay? Please try to do that. Try to be relaxed as possible. Drink water and take electrolytes if possible, okay? Things that are just going to activate that mind and make you function optimally. Guys, it's been a long year. For those of you that perhaps may not be as confident about tomorrow, may not be sure, please don't lose hope, right? As I said, at the center here this year, I had a group of students that were upgrading, and they were saying to me they didn't believe that they could understand maths as much as they do now. And so not all is lost, okay? It doesn't mean this is the end of your life and it determines your future and so on. There still could be decisions that you make right now, about your future, about next year. You do not need to give up on your dreams. One of my favorite phrases that I make is, keep your dream alive. Someday you'll understand that phrase, keep your dream alive. So, as I conclude, please ensure that you you do your best for tomorrow. Don't get discouraged if you are not as confident, but don't be overconfident if it is that you have been doing well. Keep it together. I wish you all of God's best. We love you guys, and we will meet again on Sunday. We're doing the same for paper 2, isn't it?
Yes.
Right. We're doing the same for paper 2,
Sunday.
which is on Sunday. Ngoba nesikhathi?
At 6 p.m.
6 p.m.
Do you want to do it earlier?
Guys, please let me know. Is 6 p.m. on Sunday? I think we
4.
can do earlier.
Earlier.
Yeah, I think we can
Okay.
do earlier. Yeah, I think we can do earlier. What do you think, guys, on Sunday? Right?
What
Would 4
time?
p.m. work? Would 4 p.m. work?
They'll tell us in the chat.
They're saying 4 p.m., 5 p.m.
We'll run a poll.
Okay. All right. Yeah, we'll run a poll and see what time works on Sunday. Yeah, so that we don't work too late at night. Ne? All right. Wishing you all of God's best, guys. Nyantanda, ushares uyantanda, and we are going to see you again on Sunday. Please don't forget to also tell others, and we'll let you know about all the other things that we are doing right here at the center, and also all the other programs that we have. See you again next time. Sharp, sharp.
Sharp, sharp.
Namu shares uti sharp.
They must share. They must share.
Yeah, and share.
Let people know.
Yeah,
Tag us.
please. On all those socials,
Yes.
tell others as well. Okay. All right. Sharp, sharp, guys. All right,
So
and we
good.
are out. Was it good?
It was very good.
Okay, you are seeing shares as well.
There's somebody who called you Uteni Mlungisi, like saying it in Sotho.
Kasotho. Mlungisi. Those are shares' heads, ne? That you are seeing there.
Yes, these are my heads. Alrighty. Thank you guys.
Sharp.
Oh, please let them know that the live will be available after.
Oh, yeah. And the live will be available, guys, afterwards. So for those of you who want to watch it later or want to repeat the questions, we will save it for you to be able to view throughout the night. Okay.